students, in physics, in the section optics, now let's see another experiment. We have already seen few experiments. What did we do already? We have already seen using a glass block and then finding the displacement of the ray, and then using that proving the laws of refraction, right, that we did in first practical within light section. Then we saw how to find the real depth, apparent depth, and using them how to find the refractive index of glass, refractive index of any transparent liquid. All that we saw in the second practical. Now we are going to see another one, understanding how the angle of deviation changes with the incident angle. Understanding how the angle of incident changes with the incident angle. That means here we are going to use a prism. So in the prism, when the ray goes in, first it gets refracted. The refracted ray will travel inside the prism, and when it reaches the next surface, glass to air surface, if the incident angle is less than the critical angle, then it will emerge on the other face. That means first air glass surface, it gets refracted. The refracted ray travels inside the prism. Then in the second surface, if the incident angle is less than the critical angle, then from glass air surface it comes out, it emerges. So we can draw the incident ray, we can draw the emergent ray and find out compared to the incident ray by how much the emergent ray has deviated. The angle deviation of emergent ray compared to the incident ray. That's what we call deviation. We need to change the initial incident angle. In the first phase, we will change the incident angle and see how the deviation changes. We need to understand that pattern. In theory, we studied when the incident angle gradually is increased, the deviation would fall, it will decrease. But it will decrease up to a certain point. After it reaches a certain point, when incident angle is increased, then the deviation will start increasing again. A U-shaped parabola we studied. So we are going to do this experiment and find out whether that is true. How the graph comes, how are the points? We are going to see that first point. Second point, finding the prism angle and the minimum deviation angle and thereby the refractive index of glass. Again in theory we studied refractive index of glass is equal to sine d plus a by 2. Here d is the minimum deviation. I told you deviation reduces, after a point it increases. So there will be a minimum point which we call minimum deviation. Sine of minimum deviation plus prism angle whole thing divided by 2. Divided by sine a by 2. A is prism angle. Sine d plus a by 2 divided by sine a by 2 should give us the refractive index of glass. That is what we are going to do in this experiment. Right? First, constructing the graph. Which graph? The deviation versus incident angle graph we have to construct. And then from there we can find the minimum deviation. We can find the prism angle as well. Using prism angle, minimum deviation, how to find the refractive index is what we are going to see now. The incident ray on a prism is PQ and the emergent ray is RS. Then the angle between PQ and RS is known as the angle of deviation. Listen. Let's say this is the prism. Consider a ray of incidence like this. Let's draw the normal here. That's a normal. What will happen? When it goes from air to glass, it should get refracted towards the normal. So the refracted ray would be towards the normal. See, the refracted ray, the original ray would have gone like this, but it got refracted towards the normal. it reaches the next surface. Again, we will draw the normal there, normal. So from glass to air, when it goes, it will refract away from the normal. Right, this is how the refracted ray is going to be. Let me put the arrows. This is the emergent ray, emergent ray. This is the incident ray, refracted ray, emergent ray. Let's name them. Let's say this is PQ, PQ, and this is RS. The angle between PQ and RS, you have to extend SR, you have to extend PQ and find out where they intersect. Let's extend this, let's extend this. Right. Extend this emergent ray also backwards. Right. So now you can say this is the original path of incident ray, but after it went through the prism, this is how it emerges out. This difference is what we call deviation from the original path of the ray by how much angle it has deviated. Deviation. Let's say when the incident angle I increases gradually, the angle of deviation will initially decrease. When this I, this is what you call incident angle. We studied when I is increased, deviation angle will take a shape like this. Initially it drops, after a point it increases. So there is going to be a minimum which we mark as capital D. Capital D, minimum deviation. If the prism angle is A, this is A. That means the angle between the two faces of prism, the two faces in which the refraction happens, phase 1, phase 2. The angle between those two faces is what we call prism angle. The refractive index of glass is given by n equals sin A plus D by 2 over sin A by 2. So you can find the minimum deviation by changing different I. You can measure D, then draw the graph, find where the minimum is, capital D is found. Then by another step we can find the prism angle also. Find A, find capital D, apply on this formula, you will get refractive index of glass. Look at this again. This is the incident angle, refracted angle and the refracted ray and the emergent ray. You extend the incident ray and extend the emergent ray backwards. So this is where D is going to be, D. This angle is A, right? You can use A and D and find the sign, the refractive index of glass. Let's see how this formula has come. Let's first see how this formula has come. I'll show you. We have studied this in theory. Let me show it again how the formula has come. Angles, let's say this is R1, the refraction angle. For I2, this will be R2. So you know n equals, you can say sin I1 over sin R1. This is what Snell's law is. We have proven that in the first experiment within the light section we have done. Or you can write in the other way also. Imagine if I am sending the light ray this way, it gets refracted, and if it emerges this way, you know this is reversible. Which means if I send the light ray in this path, if I reverse it, refracted ray would be like this. And again it will come in this path. Again I can write n equals sin I2 over sin R. Since the ray is reversible, incident ray, emergent ray can be reversed. Everything will be same, only the arrows will be different. You know that. Okay. Now, assuming this is the minimum deviation point, then I can say this capital D is this D. Why? At minimum deviation. At minimum deviation, this is what happens at minimum deviation. Let's get the relationship. Look at this. This is the normal we have drawn. If this is normal, here also 90. If this is R1, this has to be 90 minus R1, right? 90 minus R1. Similarly, if this is R2, this angle has to be 90 minus R2. Because this dotted line is normal, perpendicular. In triangle AQR, consider triangle AQR, top angle is A, this angle is 90 minus R1, the other angle is 90 minus R2. In a triangle, if you add all three angles, it must be 180 degree. Equate this to 180. 90, 90, 180 will be out. You have A minus R1 minus R2, 0. R1 plus R2 equals A. This is equation number 1. Equation number 1. Right. Then, let's write a formula for deviation. Let me say deviation D equals, let me write that for a general situation, right? Not for a special case, not for the minimum deviation. At any situation D, there is deviation happening at 2 points. At this point, when it deviates, when it refracts, there is a deviation. At the second point, when it refracts, there is another deviation. Let me mark that with a different color. Let's use black color for that. Here, this is the first deviation. And then here, if I extend this line, this will be the second deviation. D1, D2. If I add both deviations, that must be the total deviation we are getting. So let me write D equals D1 plus D2. Deviation at first point, deviation at second point. Deviation at first point, this total angle is I1, of that R1 is here, D1 has to be I1 minus R1. In the second point, it has to be I2 minus R2. Then I can say I1 plus I2 minus R1 minus R2. Well, let's bring it in one bracket. R1 plus R2. D equals I1, I2, R1 plus R2 is A. From this I can say I1 plus I2 equals, I1 plus I2 equals, bring this A to the other side, you get D plus A. I am getting the second equation. Listen carefully, R1 plus R2 will be equal to A. I1 plus I2 will be equal to D plus A. Understood? Now we will come to the minimum deviation point. Imagine on this same diagram, if I reverse the ray, let's say now we are at minimum deviation, that means when the ray goes like this, this is how the emergent ray is going to be, and altogether you have this much of deviation. I'll mark the deviation again. This much is the deviation. And at another point I told you the ray is reversible, which means if you send the ray this way, it has to get refracted and travel on the same path, and again refracted, it should emerge on the same path of the first incident ray. Which means if I2 is the incident angle, again look at this, I'll show it again, look at this. I1 is the incident angle, we get a deviation of D. And I told you it's at minimum deviation. At minimum deviation we are talking about, at D minimum. Minimum deviation. You already remember I showed you a graph. This is how the I versus D graph is going to be, and this point is what we call DM. This is what we studied in theory. And this is what is I. Understand, for minimum deviation, the respective angle of incidence can be only one value. If dm is there, for dm there is only one I. For other deviation values, say d1, you will have two incident angles, I1, I2. Why? If this d is not minimum, then think carefully. When I1 is the incident angle, you get d. Then I told you the ray is reversible. Imagine at I2 angle, if the ray enters into the prism, then this is how the emergent ray is going to be. This will be the deviation. Look at this incident angle, deviation. Again you will get d. If this is d, this is also d. For I1 and I2, there will be a same deviation. Usually that's how I1 and I2 comes here. See, for deviation you have I1, I2, two incident angles. For I1 incident angle, if d is the deviation, for that same deviation I2 is also possible because ray is reversible. But when this d comes to minimum, when this d is minimum, there is only one incident angle. There can't be two incident angles. What that means is, when d is minimum, you measure the incident angle here, and then when you reverse it again, you are going to get the same d. Measure the incident angle here. Both incident angles have to be same. At when d is minimum, we can say I1 and I2 will be equal because ray is reversible. For I1, if you have minimum d, for I2 also that's a deviation. But I1 and I2 cannot be different. Why? This is how the graph is. So for minimum deviation, there is only one incident angle. But you are telling there is I1 and I2. You are telling for this I1, if capital D is there, I2 also it has to be capital D. But graph says for capital D, there can be only one incident angle. Now how do we come up with the logic? I1 and I2 have to be equal. Then only at one point you will have minimum like this. Understand? Therefore, you can conclude by theory. This is from the theory, not from the practical. From the theory, you can say when d is minimum, I1 and I2 have to be equal. That means incident angle and emergent angle have to be equal. If I1 and I2 are equal, I1's refracted angle is R1, I2's refraction angle is R2. But if I1 and I2 are equal, R1 and R2 also has to be equal. R1 and R2 also have to be equal. Understood? Let me rewrite the formulae that I have written. I have already written R1 plus R2 equals A. First one. I1 plus I2 equals D. Second one. Now I have shown you at minimum deviation, I1 is equal to I2, R1 is equal to R2. Right. Let's substitute here. Careful, I1 plus I2, what we had? I1 plus I2, D plus A, isn't it? D plus A. Now in the first one, R1 plus R2 is A. For both you can say R. R plus R is A. 2R is A. R is A by 2. In the second one, I1 plus I2 means 2I, right? D can be replaced by capital D. Why? I said minimum. At minimum only you call it capital D. I is equal to D plus A by 2. Refraction index is sine of I divided by sine of R. Incident angles sine divided by refraction angles sine. Substitute sine D plus A by 2 divided by sine A by 2. Right? This is what the theory is. Understand, this is how the formula we derive. N refraction index equals sine capital D plus A by 2 divided by sine A by 2. All what you need to find refraction index is D and A. What are the materials and apparatus required to do this experiment? Usually we use an equilateral prism here, equilateral prism, a drawing board, drawing pins, optical pins. Drawing pins is to fix the paper on the drawing board. Optical pins will be used to demark the lines. The incident ray, emergent ray can be marked by optical pins. White paper, if we do this on a white paper only, we can draw the lines. And a meter ruler just to draw the lines. Method to find the minimum deviation angle. Fix the paper on the drawing board with drawing pins. Draw a straight line in the middle of the paper along the longer side of the paper. That means if your paper is like this, right, this is the longer side, this is the length. In the middle, draw a line. Keep your meter ruler and draw a line. Not exactly it has to be in the middle, but drawing it in the middle, you will have enough space up and down to draw the rest of the lines and do the workings. Mark 6 different points on the line in approximately 4 centimeter distance. That means, see, you have to mark 6 points, right? 1, 2, 3 likewise. So if you mark 6 points, there will be 7 gaps, because you can't mark 1 point at the edge here. So from the edge in 4 centimeter 1, likewise. Why 4 centimeter? When you mark 6 points with the space on both sides, 28 centimeters will be gone. Your paper is approximately 30 centimeter. So to get the maximum use of the paper, we say mark the points at 4 centimeter gap. So that's not a theory or rule or anything. But to get the optimum use of the paper, we mark it at 4 centimeter gap. And draw the line PQ at each point with making 60 degree, 50 degree, 45, 40, 30 and 20 angles with the line. You remember PQ was our incident line. I am taking 6 different incident lines. So I am drawing PQ again and again 6 times at 6 different points. But not with the same angle. I am changing the angle. See, initially I am taking 60 degree from the given line. So initially I will mark it at 60 degree. Then I will mark it at 50, 45. So actually when I am marking this as 60, the I am considering is only 30. Because the angles I am drawing with the horizontal line we have drawn, not the normal. Right, since we have that line already, from that line you measure the angle and draw the line. In the protractor also 0 is at the horizontal line, right? So it's easy, from the horizontal line you measure the angle. But careful, I means incident angle means that is not the incident angle. I is the angle with the perpendicular. Right, so if you are drawing this line at 60, I is 30. Remember that. 6 different points, you take 6 different angles. And then what do we do after that? Place the prism such that one face of the prism AB to be on the line XY and the point Q of 60 degree line to be in the middle of AB. Keep the prism such that one face is with this. Careful, sometimes there might be prisms with one side rough edge. Usually for these kind of practicals, we don't take that prism. By mistake, if you have taken such a prism where one surface is rough surface, then make sure that rough surface is here. Why? We need these two surfaces to be clear. There must be smooth surface. There has to be refraction happening in. Suppose if you have a prism with one face rough, make sure the rough face is kept here. Clear? Right. Keep it. And in the first line, the Q has to be somewhere in the middle, right? Because then only you can see the refraction and everything. If you take it here or here, then getting it can be difficult. If you take it too close to here, sometimes it can get refracted and come to this side. So when you look from here, you won't see anything. Similarly, if you draw it here, the refracted ray is too small, right? The deviation measuring and drawing the lines, everything will be difficult. That's why we say make the Q somewhere in the middle. You can shift it, right? You can shift the prism and keep it such that one face is aligned with this line and this Q point is not exactly in the middle, somewhere in the middle of AB. Fix 2 pins P1 and P2 on the incident line at significant distance. On this you can mark P1 and P2 in practical previous one. I explained why the points have to be in maximum distance, because if you increase the distance between two pins, any errors that we make, the impact of error would be minimized. Impact of error will be minimized. Look through the face AC of the prism and fix two pins P3 and P4 to be collinear with the images of P1 and P2. Look from this side. You will see two images of P1 and P2. P1, P2 images you will see somewhere here. So fix another 2 points here to be in line, to be collinear. All four should look like in the same straight line. What are the four? P1's image, P2's image, the new pin P3 you are fixing, the new pin P4 you are fixing. P1 image, P2 image, P3, P4 all should look like same straight line. After you finish fixing P4, when you look, you must see only P4. P3 or P1's, P2's images you must not be able to see because they are all in the same straight line. I'll show that in the experiment. Look through the AC and fix it. Mark the other edges of the prism and remove the pins. Make sure before you remove the prism, draw these lines. Otherwise, you wouldn't know when you extend this line, you wouldn't know up to where you have to draw this, right? Basically, the point of emergence you wouldn't know. Because of that, we particularly want this side. Mark that surface and then draw the line connecting P3 and P4. Extend it until AC. Let R be the point where P3, P4 intersects AC. QR is the path of the ray within the prism. Extend it. See where this line intersects the face of the prism. That is R. Let's mark it as R. Q already we have marked. QR must be the refracted ray's path. RS, if I mark this point as RS, that's the emergent ray. Extend PQ and SR to intersect and find the angle between them. All what we want is deviation, right? So you extend this line, extend SR line, find where they intersect at the point of intersection, by how much the ray has deviated. You must be able to measure with your protractor. We should have added here one more apparatus, protractor. We need protractor to measure the angles. Right. This is the deviation when incident angle is 30 degree. Even though we mark the angle as 60 degree, remember that is not with the normal. With the normal angle is 30. So incident angle 30, now you have got the deviation. What next? Repeat this for the other 5 points also. Now we have done for only one incident angle, right? We need multiple angles to draw the graph. Repeat this for other angles. Measure the angle of deviation in the similar method for other incident angles also. Draw the graph D versus I. Find the minimum point of the graph D and the incident angle at this point I. Right? I versus D. Right? If you have got 6 points, mark those 6 points and see where I and D are equal. Where D is minimum. Where D is minimum. Right? Repeat. Where D is minimum. At D is minimum, actually if you have done it correctly, very difficult to do this experiment to that level of precision. But if you have drawn it, if you have done the experiment properly without any mistake, then when we find the D minimum, I1 and I2 has to be equal. We are measuring I1 and I2. Both sides angles. I1 and I2 have to be equal. That's what we studied in the theory. Then we have to find the prism angle. We need A also. So this is the logic for that, right? Two parallel rays, if they fall on two faces of the prism, there will be some reflection. So the reflected ray you must be able to see from here, and the reflected ray you must be able to see from here as well. Draw those lines, extend them. This angle will be equal to twice the prism angle. Twice the prism angle, right? Shall we check how? Listen. This is the prism. Two parallel rays, ray number 1, ray number 2. Then there will be reflection here. reflection, reflection. Extend these reflected rays. This angle we are telling that has to be twice of the prism angle. We'll see how it comes. Draw the normal. Let's draw two parallel lines to these two. One through the top of the prism, other one through this point where these two rays extended, they meet. Let's take this as I1 and I2. If this is I2, this has to be 90 minus I2, agree? And this has to be 90 minus I1. Why? This is the normal. If this is 90 minus I1, this angle also has to be 90 minus I1. Why? These two are parallel lines. These two are parallel lines. 90 minus I1. Similarly, the other angle, that has to be 90 minus I2, because if this is 90 minus I2, this has to be 90 minus I2. From this I can say A equals 90 minus I1 plus 90 minus I2. 180 minus I1 minus I2. That's A. Now let's measure this angle. Look at this carefully. If this is I1, this has to be I1. Let's use a different color for that. This will be I1. Why? The incident angle and the reflection angle must be same. I1, I1. Then this will be 90 minus I1. Then look at these two straight lines, opposite angles, 90 minus I1. Similarly, you can show this will be 90 minus I2. Similarly, you can show this to be 90 minus I2. Now look at this. This is 90 minus I1. This is also 90 minus I1. So the angle between these two purple lines has to be 90 minus I1, 90 minus I1, twice 90 minus I1, twice 90 minus I1. And that has to be the angle here, this one. Why? These two, look at the angles I am marking in red color. These two angles must be same because two parallel lines and there is one line that intersects. This angle is twice 90 minus I1. So this angle also has to be twice 90 minus I1. Right? Let me mark it here. I will mark it here. Twice 90 minus I1. In the similar process, you can say this angle is twice 90 minus I2. So if you measure the angle between these two, right? The angle between these two, twice 90 minus I1 plus twice 90 minus I2. Without the 2, if it is 90 minus I1, 90 minus I2, that will be A, prism angle. Since you have twice, that has to be 2A. That has to be 2A. That's what we have studied in theory. Right? Two parallel rays falling on two faces of a prism. Look at the reflection of those two. Reflection of those two. The angle between those two reflected lines have to be twice the prism angle. Twice the prism angle. That's the concept we are going to use here. That's the concept we are going to use here. Two parallel rays falling on a prism on two different faces. They reflect, connect them, measure the angle, twice the prism angle. Like we did previously, draw these two lines and then place the prism such that these two lines intersect the two faces of the prism. You can mark 2 pins here. Observe the 2 pins from this side. Make sure you observe the reflection, not the refraction. You are going to observe the reflection. So observe from this side. And then to be collinear with the images, you mark another 2 pins, connect them, you will get the reflected ray. Repeat that for the other side also. Then you extend this line, you can find the twice of prism angle. Divide that by 2, prism angle is ready. So we already know how to find the prism angle, we already know how to find the minimum deviation. Put those things together, you can find refractive index of this prism. Shall we see how to do it in the lab? Let's take the apparatus and try it. Hello students, in this practical we are going to see how to find the minimum deviation of a ray that enters into a prism. So we are going to see a ray entering into prism, and when it exits from the prism, there will be a deviation between the incident ray and the emergent ray. So we are going to see the deviation, how the deviation changes, and we are going to find the minimum deviation. Why are we finding minimum deviation? We can use the minimum deviation to find the refractive index of the medium. Medium of which one? Medium of the prism. So we are going to use this practical to find the minimum deviation angle in order to find the refractive index of a prism. So the materials and apparatus required for this practical include, we need a prism. We are going to find the refractive index of this prism. We need a drawing board. On this board we have to fix the A4 sheet. So this is the A4 sheet we are going to use. How do we fix it? We need the drawing pins, and then we need these optical pins to draw or to mark the line of incidence and the line of emergence. We need 4 optical pins. To measure the angle, we need the protractor. We need a pencil to draw the lines, and we need a meter ruler. Usually in practicals we use meter ruler, not the foot ruler. So in the exam, if they ask you the apparatus and materials, you have to mention meter ruler, not the foot ruler. Now we will see how we can do this practical. So first what we do, we take the paper and we will draw a horizontal line in the mid of the paper, a straight line. Why do we draw that? On that only we are going to keep the prism and measure the angle of incidence, a horizontal line. You know, in physics practicals, we don't usually take one point and come to the conclusion. We take multiple number of points and we draw a graph. From the graph only we have to come to the conclusion. So to find the minimum deviation angle also, we take a similar approach. We will be taking different angles of incidence. And for each angles of incidence, we will measure the angle of deviation, and we will find out at which point the minimum deviation happens. So to mark different angles of incidence, we take a straight line, and one by one we will be marking the lines of incidence. So first we will draw the line where we are going to keep the prism. Somewhere in the middle you have to draw this line. Usually we draw the line with pencils in practicals, but here for you to see it clearly, I will be using a pen. But when you are doing practicals, you have to use pencils in a lab. Now horizontal line is ready. This is where I am going to keep the prism. So I told you we are going to take multiple angles of incidence. Let's start the practical with 30-degree angle of incidence. So 30-degree angle of incidence means if I am going to mark 30-degree at this point, with the normal it has to be 30-degree. With the normal it is 30-degree, meaning from the horizontal line that I have drawn, it has to be 60-degree. So let's first mark 60-degree. Let's mark 60-degree with horizontal, meaning with the normal, with the perpendicular, it will be 30-degree. That will be the line of incidence. Now what we will do, let's fix this paper on the drawing board. We will fix 2 pins, keep the prism, and observe how the line of emergence comes out of the prism. Right. So, let us fix the paper on the drawing board. For that we have the drawing pins, we will fix them. Right. Now, what we do? Let us keep the prism such that one side of the prism is in line with the line that I have already drawn. So, I have kept the prism in line with the line that I have already drawn. Now, what next? Let us take two optical pins and fix the optical pins on the line of emergence that I have marked. So, when you are fixing these two optical pins, you must be aware that we have to fix these pins as much distance as possible. Why do we do that? If you fix the pins closer, then the chance of error, the possibility of error is high. When you fix them at as much distance as possible, you can minimize the error. So, let us fix it. Let us fix one point closer to the prism. Let us fix the other pin as far as possible from the prism. So, let us fix the pins. Let me fix the first pin close to the prism. Let us fix the other pin in as much distance as possible. Now, these two pins indicate the line of incidence. You know, the ray comes inside the prism. It will travel inside the prism. I do not know how it travels inside. All I can see from this end of the prism, I can see the emergent line. So, that is what I am going to do first, how the emergent line comes out of the prism. For that, let us take two pins and I will be observing the emergent line from this end, and I will fix these two pins to be in line with the images of the already fixed pins. So, now you can see the two images which are already in line. Now, let me fix the first pin to be in line with those images. In the same line, let me fix the second pin also. Now, let us remove the pins and the prism. But before you remove the prism, make sure you mark the borders of the prism, because to measure the I1, I2 angles, that means the emergent lines angle, incident lines angle, we need the prism borders. We have drawn only one border, so let us draw the other two borders as well. Now, let us connect the two points that we marked and we will draw the emergent line. Let us draw it up to the prism border and let us extend that further so that I can measure the angle of deviation easily. Similarly, the incident rays line also I have to extend until it meets the emergent line for me to easily measure the angle of deviation. So, the blue color line is the incidence ray, red color line is the emergent ray. In between how the ray would have travelled, you can see this is the point where the ray enters into the prism. This is the point where the ray exits from the prism. If you can connect those two, you can find out how the ray would have travelled within the prism. What we measure as the angle of deviation is the angle between incidence ray and the emergence ray. So let's measure the angle of deviation. Right, the blue color is the incidence ray, red color is the emergent ray. See the deviation, it has deviated 48 degrees, it has deviated. That means for a 30-degree incidence angle, the deviation angle is 48 degrees. Let's mark this outcome on our table and we will repeat this practical for next 6 different angles, and then we will draw the graph to find out at which point we get the minimum deviation. Theta is the angle with the line that we have drawn. The angle with the border of prism, that we took it as 60 degree. If that is 60, I1 is the angle of incidence which we measure from the normal. So it has to be 90 minus theta, which is 30 degree. D we measured, it was 48 degree. I2 is the emergent rays angle. So that we have to again measure from the diagram we have drawn. So we will measure the emergent lines angle. With horizontal we get 14 degree. With horizontal 14 means with the normal it must be 90 minus 14, which is 76 degrees we will get. So I2 is 76 degree. 76 degree. We have done this exercise for 30 degree I1, 30 degree angle of incidence. Let's repeat the process for 40 degree angle of incidence and see what is going to be the deviation. So let's redo this exercise for 40 degree angle of incidence. So you know 40 degree angle of incidence means with the border of the prism we have to take 50 degree, 50. Let's mark 50 degree, which means from the normal it will be 40 degree, angle of incidence 40. That will be the line of incidence. Let me extend that further for me to easily measure the deviation. Now what do? Let's keep the prism again like we did last time. Make sure you keep the prism to be in line with the line that we have already drawn. We have already drawn a long line. So one side of the prism has to be in line with this line that we have already drawn. Now let's fix 2 pins to mark the ray of incidence. As I already told you, mark one pin as close as possible to the prism and another pin as far as possible in order to maximize the gap between the 2 pins. Right. So we have fixed the 2 pins to mark the line of incidence. What do we do next? From this side of the prism, I have to see whether I can see the emergent line, emergent ray. So as you know, the ray will be traveling inside. So I don't know how the path is inside, but I can see the emergent ray. After I construct the emergent ray, then I can draw how the ray would have traveled inside the prism also. So when we see from this end, the 2 images have already coincided. Now let's fix this first pin to be collinear with those images. And on the same line, let's fix another pin. Now let's remove the pins and mark the borders of the prism. We can remove the prism also and let's draw the line of emergence. We already marked the 2 points. Let's connect them. And extend the line until it meets the line of incidence so that I can measure the angle of deviation comfortably. Now let's measure the angle of deviation. We have got approximately 40 degree as the angle of deviation. You can see this is the line of incidence and this red color one is the line of emergence, and you can see the difference. There is approximately 40 degree deviation. So, we have taken angle of incidence of 40, for that the angle of deviation we are getting is also 40. Now, let us mark this on our table. Theta is the angle with the horizontal line, which is 50, and I1 is the angle of incidence 40, and the deviation we have got is also 40. What is I2? The angle of emergence. Let us measure the angle of emergence. So, as you can see, this is the line of incidence, this is the line of emergence. So, how the ray would have travelled inside the prism, you can connect the 2 points, the point of incidence and the point of emergence. Right. So, that is the refracted rays path within the prism. What we need now is to measure the angle of emergence. From the horizontal line, from the side of the prism, we measure 32 degree, which means with the normal it has to be 90 minus 32, which is 58 degree. So, I2 is going to be 58 degree. What is I2? The emergent line angle with the normal at the point of emergence. So, we usually measure the angle with the side of the prism. From 90 you subtract that, you can find out the angle it makes with the normal. So, here it is 32 degree, which means on the other side with the normal it has to be 58 degree. Let us mark this on our table. So, I2 we measured, it is 58 degree. We have done the practical to 30 and 40 degrees now. Now, you know, when it comes closer to the turning point, it is better if we take the points closer. That means, now we have taken at a 10 degree gap. Next one let us take at 5 degree gap, because around 45-50 degree we expect the minimum deviation that we studied in theory. It is around that angle we have to get the minimum deviation. So, rather than taking 50 degree at once, let us take 45 degree and see how the deviation is. Let us shift this I1 5 degree by 5 degree now, since we are closer to the turning point of the graph. Right. So, now the next angle we are going to take is 45 degree. One more thing I have to tell you, students, when you are doing this in the lab, when you do it yourself, you can mark all 6 lines of incidence on the same paper. Here, for it to be more clearer to you, I am drawing only 3 in one paper and I will draw the other 3 in another paper, just to make it clear for you, only for that purpose. Usually, you can do all 6 lines of incidence, you can draw them on the same paper itself. Right. Now, I need to take 45 degree. Let us mark 45 degree. degree from the normal, 45 degree from the horizontal, both are same, 45. Let us draw the line of incidence. Extend it. Right. As I already told you, the prism has been kept. One border of prism has to be in line with the line that I have already drawn. What next? Let us fix 2 pins to mark the line of incidence. First pin, you remember I told you have to fix the 2 pins vertically and in as much distance as possible. So, fix the first pin closer to the prism, second one away from the prism. Now, the 2 pins have been fixed. What do we do next? From this side, we have to see the line of emergence. So, when you see from this side, first you have to adjust your line of sight and make sure that both images are in the same line. Then, to be in the same line with the images, you fix this first pin. Also, you fix another pin to be in the same line with the images and the first pin. Now remove the pins. Mark the border of the prism. Right, we will remove the prism also and draw the line of emergence with red color. And we can measure the angle of deviation. We get approximately 37 degree as the angle of deviation. This is for 45 degree angle of incidence. We have taken 45 degree angle of incidence. The deviation is 37 degrees we are getting, 37. Now we will mark this in the table that we have. Now we have done this for 45 degree, theta is 45. Theta 45 means I1 is also 45, 90 minus 45 is 45. And the D we measured was 37 degrees. Angle of deviation 37 degrees. Now let us measure how much is the angle of emergence, the I2. We get an angle of emergence of, with the horizontal you can measure, that means with the side of the prism you can measure, it is 38 degrees, approximately 38 degrees, which means from the normal it has to be 90 minus 38, which is 52 degrees. Angle of emergence is 52 degrees. You can also mark the refracted rays path, even though that is not required. You can mark that. See, this is the point where the ray enters into the prism. This is the point where it exits from the prism. So if you connect the 2 points, then you can see how the ray has traveled within the prism. Now let us mark this angle of emergence on the table. So I2 we measured now, it is 52 degrees, 52 degrees. So for an I1 of 40 and 45 we have done. Let us increase it by another 5. Let us make it 50 degree and see how I2 and D are going to be. So we have done the experiment for I1 of 30, 40 and 45. Next we have to do 50. Usually we can take all 6 incidence lines on the same paper, but here for it to be more clear to you, I am taking 3 incidence line on one paper and the other 3 incident lines on another paper. That means 50, 60, 70 degrees, let me take on a separate paper to have more spacious diagrams and for it to be more clear to you. But when you are doing the experiment in the lab and when you are writing the answer in the exam, you can write it as all 6 experiments, all 6 readings are taken on the same paper itself. Right. So now let me mark 50 degree angle of incidence. $50 from the normal, so 40 from horizontal. That is a line of incidence. I am extending that so that it will be easy for me to find the deviation. Now let us mark 2 pins and keep the prism. 2 pins. Do not forget what I told you, the 2 pins have to be vertical and you have to fix them in as much distance as possible. Then keep the prism in line with the line that we have already drawn. And observe the images from the other side of the prism, like we did for the other angles also. Check the 2 images to be in the same line and then fix the pin to be in line with the same images. Fix the second pin also in the same line. Right. Let's remove the pins and draw the borders of the prism. Now we can draw the line of emergence. Make sure you extend the line of emergence until it meets the line of incidence. Now we can measure the angle of deviation. We get 40-degree angle of deviation. You can see that clearly 40-degree angle of deviation we are getting. This is for 50-degree angle of incidence. We are getting 40-degree angle of deviation. Let's measure I2 also. I2 with horizontal you are getting 41, which means with the normal we will get 90 minus 41, which is 49 degree. So 49 degree is the angle of emergence. I2 is 49 degree. Let's mark all this on our data table. We took a theta of 40, which means I1 is 50, and the deviation we got is 40, and I2 we got 49 degree. These were the readings for 50-degree angle of incidence. So now we can see we have already reached the minimum and the values have started increasing. Can you see? The D has started increasing, which means we have already passed the minimum deviation point. Anyway, we need to get at least 6 points to make sure our graph is correct. So now we can take 60-degree angle of incidence and 70-degree angle of incidence. Next two we will take 60 and 70 for I1. For an I1 of 60, we have to take theta to be 30. With this horizontal line, I have to take 30 degree. That means with the normal, it is 60. I1 is 60. Let me draw that line. Now let's keep the prism and fix the 2 pins to mark the line of incidence. Fix them vertically and in as much distance as possible. Now as we did earlier, keep the prism to be in line with the line that we have drawn already. Let's observe the images from this end, from this side of the prism, and mark the other 2 pins, which will show us how the emergent ray is traveling. You can see the 2 images are already coincided. Now let me fix this pin. And another pin. Mark the borders of the prism. Remove the prism and draw the line of emergence. And let's measure the I2 and D. We get the angle of deviation of 41 degree, 41, and I2 from horizontal when I measure it's 50, which means from the normal it has to be 40. I2 is 40 and angle of deviation is 41 degree. Let's mark this in our table of data. So this time we have taken a theta of 30, which means I1 is 90 minus 30, that is 60. And the deviation we got is 41 degree. and I2 was 40. So we can see now after the minimum point, the D keeps on increasing. It has come to 40, now 41. So you can expect when I do it for 70 degree, it has to be even more a higher figure. Now let's repeat the process for 70 degree and observe the values. With that, we will have 6 values. We can draw the graph and we can find the minimum value. All right, students, the last one, 70 degree. Let's mark 70 degree. 70 from the normal means 20 from the horizontal. Now we can mark the incident ray. Then we will keep the prism and mark the two pins vertically and in as much distance as possible. Keep the prism and let's fix the two pins to mark the ray, emergent ray's path, emergent ray. So to be in line with the images, you fix this pin and another pin to mark the emergent ray. Now let's remove the pins, mark the borders of the prism, and draw the line of emergence. Let's measure the angle of deviation. We get 45 degree. For 60 degree angle of incidence, we got 41 degree. Now for 70 degree angle of incidence, we get 45 degree as the angle of deviation. Also, let's measure the emergent rays angle. With the side of the prism, it makes an angle of 55, which means with the normal 35. I2 is 35 and the deviation is 45. Let's mark this on the table. So now we got a theta of 20, I1 of 70 and the deviation was 45 degree and I2 35 degree. Now some of you might be wondering, why are we taking I2? Because we are going to draw the graph between I1 and D. There is this reversible principle. That means in the prism, you can interchange the ray of incidence and the emergence ray. That means if you change the emergence ray as incident ray, then the previous incident ray will be turned into emergent ray. Which means when we take I2 as the angle of incidence, then the I1 will be the angle of emergence. For that case also, deviation will be same. So actually when you do this for 6 different points, 6 different angles of incidence, that is almost equivalent to taking 12 different data points, because you have got 6 different I1 values and their deviations. For each of them, you have got 6 different I2 values also. For each of them, you have got one I2 value, altogether 6 I2 values also. For those I2 values also, it's going to be the same deviation. Which means, according to the reversible principle, if you take I2 as the angle of incidence, I1 will be the angle of emergence. If you take I1 as the angle of incidence, I2 will be the angle of emergence. Whichever the case, D is going to be same. D is going to be same. Right? So, once they have asked in the exam, how many minimum points you have to take to draw this graph. So actually, if you have taken at least 3 points, then you will have 6 different points. Why? because you have taken I1 thrice. For each of those I1s, you will have 3 I2s. So, if you have taken 3 different I1 values, for each of them there will be an I2 value. So, you can take 3 I1 and D, then you can consider the I2 values again as the angle of incidence. So, altogether you can take 6 angles of incidence with 3 experiments itself, 3 experiment points itself. Now, we will see how to draw this in the graph and find the minimum deviation point. So, now you saw that we need the prism angle to be found in order to find the refractive index of this prism material. So, how do we find the prism angle? We will take this paper, fix it on the drawing board. Let us fix the paper on the drawing board, and then we have to draw 2 parallel lines in a gap of 1.5 centimeters, 15 millimeters approximately. 2 parallel lines in a gap of approximately 15 millimeters. So, let us draw that 2 parallel lines. Make sure you draw them parallel. So, now we will keep the prism such that the angle that you want to measure, the prism angle that you want to measure has to be in between the 2 parallel lines that you have drawn. And what we are going to do now, a ray that comes this way will reflect on this side of the prism. So, I am going to watch from this side how that reflects. I am going to observe the reflected ray from this side. Similarly, the other ray would be reflecting on the other side of the prism, right? The 2 sides which make the prism angle that you want to measure, and the 2 rays will reflect from each angle. So, we have to observe those 2 reflected rays and mark them, right? So, let us first observe one of these lines. For that, I have to fix 2 pins to mark these incident rays. So, students, now you can see the images of both pins that have been aligned here. I will show you the images. See, the first pin's image you can see there. Similarly, the second pin's image also. Now, both images are aligned. You must understand the reflected ray strength is less. So, the images you see from the reflected ray will not be as clear as we see from the refracted ray, because the percentage of ray that gets reflected is less. So, to make it clear to you, I have kept a black color background so that it looks more clear to you. Now, let us fix the pins to be aligned with the images. Now, let us remove the pins and fix it to the other ray, and let us observe the reflected ray from the other side of the prism. First one and the second one. Now, that will show us the reflected ray in this direction. Now, let us remove all the pins and the prism. Let us draw the reflected rays that we have marked. Now we have drawn the two incident lines and the two reflected lines. Now the angle between two reflected lines will give us twice of the prism angle. So I need to measure the angle between the two reflected lines and divide by 2 to get the prism angle. We get 117 degree as the gap between the difference between the two reflected lines angle. So 117 degree gives us twice of prism angle. To get prism angle, I have to divide 117 degree by 2. So now we have found the prism angle. Let's see how, using the prism angle and the minimum deviation, how we can find the refractive index of this prism material. Right. Now the readings we have got, I have marked here. This is the angle we marked with the horizontal line. Then this was the incident angle. If this is 60, this has to be 90 minus 60, 30. I2 76 and deviation 48. We have written all that. Now let's put them into graph. This is what I am going to take in the x-axis. This is what I am going to take in the y-axis. Independent variable, right? I1 is what I was changing in my own. We will take that in the x-axis. According to that, deviation changes. The dependent angle, dependent variable is deviation. That's why I am taking that in the y-axis. We need from 30 to 70. You know, we have 75 sections here. We will take 3 by 3. Then let me draw the axis first. That's the x-axis. That's a y-axis. I1. Or you can even just say I and R. Not R, I and D. Deviation. Deviation. Let's mark the points. Before that, we will get the scale, right? We need up to 70 maximum. We have 25 sections. We will take 3 by 3, 25, 3 degree. We can get 75 degree maximum. So 3 by 3, 6. 6 degree, 12, 18, 24, 30, 36, 42, 48. 3 by 3 is what I am taking, but I am marking the alternative ones. This is 42, then the next has to be 45. I am not writing 45, I am writing 48. This will be 54, 60, 66, 72. This is in degrees. Similarly, y-axis, there are 18 sections. We need maximum 48. So y-axis also we can take 3 by 3. We will get 18 into 3 up to 54 we can go. Six, 12, 18, 24, 30, 36, 42, 48, 54. First point is I1 30 degree, deviation 48 degree, 30 and 48, 30 and 48, 30 and 48, 48 is here, 30 is here. That is the first point, first one. Second one, 40 and 40, 40 degree and 40 degree, 36, this will be 39, 40 has to be 1/3 within this section, 40 here, again 36, 39, 1/3 here, 36, 39 here. That will be 40, 40. 45, 37, 45 degree, 45 degree, right, this is at 40, 45 has to be this line, 45 and we got 37, 45, 37, 36, 37. Right, that is 45, 37. Next, 50 and 40, 50 and 40, 50 and 40. 40 has to be here itself, 50. This is 51, a little before that. That is 50 and 40. 60 and 41. 60 and 41. 60 is here. 60 and 41. This is 42. Right. 41. And 70, 45. 70, 45. 70 has to be 69, 70, 45. 42, 45. 70 and 45. That's how we are getting the points. So this point seems to be a little away from our points. We can take these three connected down and then these are going up. Let's connect. It has to be a freehand curve. Don't break them. There shouldn't be a kinked graph. Kink means a break. There shouldn't be a break there. It has to be a curve. Let's draw the best curve we can draw here. We can get a graph like this. Only one point seems to be deviated from our points. See, let me highlight the points again. This was one point. This is another. Right. This is how we are getting. One point is a little deviated from the graph. Now we can see the minimum is here. Minimum is here, right? Just below 37. Just below 37. And the I for that minimum has to be here. Let's mark that. This is where we are getting the incident angle when D is minimum. Also, this is the D minimum value we are getting. Let me redraw that. That's the D minimum value we are getting. Check that, check that. Right. We know this point was at 37 degree. It's a little bit below 37 degree, right? But not 36. It's above 36, below 37. So maybe we can take it as 36.5 degree. This we can mark it as 36.5. According to my graph, this can be marked as 36.5 degree. 36.5 degree. And the minimum deviation for that, the incident angle we are getting, this is 42, 45. It's not in the right middle, a little towards the right side. So can say around 46.5 degree. 46.5 degree. That is 46 degree and 30 minutes, right? 46 degree and 30 minutes. Approximately 46 degree and 30 minutes. This is 36 degree and 30 minutes. So the answer for minimum deviation D, 36 degree, 30 minutes. Answer for A, I we are getting, I we get 46 degree, 30 degree, for 30 minutes. 46 degree, 30 minutes. Right? That's the D. Now let's see how to do the calculations. 36, 30. The minimum deviation from the graph is 36 degree, 30 minutes approximately. The incident angle at that point, 46, 30, isn't it? 46, 30. 46 degree, 30 minutes. The angle between two reflected lines from the faces of the prism, we measured that was 117 degree. 117 degree. Divide that by 2, you will get 58 degree, 30 minutes, right? Now we will say refractive index of prism, sin dm plus a by 2. Dm is here, a is here, add them and divide by 2. You get 58, 36, that will be 94, 95. Divided by 2 will be sin 47.5 degree, 47 degree, 30 minutes. Divided by sin a by 2. A is 58, 30 by 2 means sine 29, 15 minutes. Now this you can use your sine tables and find 47, 30 degree. If you find the correct values, using the sine table we are getting 0.7373 for that, 7373 for that, and then for sine 29, 15 you get 4886, 0.4886. Divide them, you are getting 1.509 is what we are getting. If I round it to 2 decimals, 1.51. Okay. You can double check the values with the calculator. Sine 4730. Try to get it with the table. What you can do, if you don't have 4730, you can take 47 degree, 48 degree, get an interpolation and get the answer. Right. Not the exact answer, there will be a slight difference because sine curve is not a straight line. But 47, 48, get the values and get the midpoint of them would be approximately this. 29, 15 also you can do an interpolation. That means take 29 degrees readings, 30 degrees readings, get the difference, divide that by 4 because 15 minutes means 1/4, right? With 29 degrees reading, add 1/4 of the difference between 29, sine 29 and sine 30. Like that you can get these two and then divide, you get 1.51. So we studied in theory also glasses refractive index is 1.5. We are getting an approximate answer closer to that 1.51 is what we are getting. Understood? This is how we do the experiment of finding minimum deviation and finding the prism angle, using those how to find the refractive index of the material of prism. Clear? We can actually do this experiment later with a spectrometer also. So this same experiment, same concept can be done with spectrometer, without spectrometer. This one I have done without a spectrometer, right? Now let's see what kind of questions have come on this area, on this experiment in your past paper questions. That means in the GCE advanced level exam, in the structure section, the structured essay questions. In that section we get questions from practicals, and from light every year we get a question. We will see what question has come from this particular experiment. Okay, from this experiment in 2019 there was a question of which part of that was from this experiment, right? Previous part was using the spectrometer. So let's not do the spectrometer part now. Let's do the rest of it. But anyway, from the spectrometer we need one small thing. Check this. We will be discussing this in the spectrometer experiment again, but we might have done this in theory. When the telescope is at positions T1 and T2, the readings of the spectrometer are 279, 58 and 38, 2. See, T1 means when the spectrometer reads this reflection, T2 is the other side reflection. Note that the telescope passes the 0 of the main scale when it is moved from T1 to T2. Calculate the prism angle A. Those who studied about the spectrometer would know that. Others just concentrate. I'll try to explain this to you. If this is how the scale is, it's a round scale we have in a spectrometer. Let's say this is where 0 is, this is where 90 is, 180 and 270 degrees. First reading was at 279. So it must be somewhere here. 279. This is T1. Second reading is at 38. 38 would be somewhere here. T2. All what I know, the angle between these two will be 2A, right? The angle between these two will be 2A. So I have to get the difference between these two readings. But the complication we have, see now it's a 278 or 279. When it comes here, 360 is completed. Then it starts again from 0. So we have to measure this difference separately and this difference separately. This will be, assuming this is 360, when you finish one full rotation, this is 360, right? So this difference will be 360 minus 279. And this difference will be just the reading itself, because from 0 you are again starting to count. 38 degree, 2 minutes means this is 38 degree, 2 minutes. 38 degree, 2 minutes. This will be 360 degree minus the reading you got here, 279 degree and 58 minutes. After we do practical number 19, where we will be discussing about the spectrometer and finding the prism angle using the spectrometer, you will understand this further. For now, 2a, I can say this difference, 360 minus 279, 58 plus here 38 2 degree, 38 2 minutes. That will be, if it is 280, you have 80 degree and 2 minutes, 38 degree. So it's 118 degree, 4 minutes. Check that carefully. 280, 360, 80. So here you have 80 and 2 minutes. There are 38, 118, 2 minutes. Divide by 2, you can get A. 59 degree, 2 minutes. 59 degree, 2 minutes. Clear? That's the prism angle. So this prism angle, how to find it? Without the spectrometer we studied. Get the difference between these two. Get the angle here. That has to be twice of prism angle. So that's what I got as 118 4 minutes. Divide by 2. 59 degree 2 minutes is the prism angle. To determine the angle of deviation of a light ray by the given glass prism, a student measured the incident and emergent rays I1 and I2 respectively, as shown in figure 2. The graph shows the variation of I2 with I1. Okay. Right, this is I1, I2. This is the experiment we did. But they have drawn the graph between I1 and I2. I1 and I2, not D. We usually take I1 and D here. But they have drawn I1 and I2. Write down an expression for the angle of deviation in terms of prism angle and the angles I1 and I2. You know, we studied that. We studied I1, I2 minus A. We studied that from the theory. Straight away you have to write it here. No proving, nothing. Just write this answer. Marks will be given for this line only. Whatever else you have written, doesn't matter. If this answer is there, that is where the marks is going to come for you. Next. Determine the minimum angle of deviation D by using the graph. By using the graph. You know, when angle of deviation is minimized, I1 and I2 have to be equal. I1 and I2 have to be equal. So let me go to the graph and find out on this graph where I1 and I2 are equal. Remember, this is not a D graph. Careful. I1 and I2 is what we have in the x-axis and y-axis. I need to find the point where deviation is minimum. To find deviation is minimum, you know I1 and I2 are equal. In the graph now, I need to find where I1 and I2 are equal. For example, if you look at this point, I1 is somewhere around 76 degree, I2 is 30. I1 and I2 are not equal. If you look at this point, I1 is 15 degree. See the scale, how they have taken? They have taken, if this is 30, let's try to understand the scale. Here it is okay, 30. So they started from 30, right? Then every two sections they take it as 10 degree. 30, 40, 50, 60 likewise. Similarly, here also they are starting from 30. This is 30. They are not starting from 0, 0. Careful, now they are starting from 20, 20. And then 30, this is 40, 50. Again, same scale in the y-axis also. I need to find where it is equal. You know, do you know how the y equals x graph has to be? Now, this is a little bit outside the experiment they have asked. Now, you have to think a little bit and answer. Because we normally don't draw I1, I2 graph. In I1, I2 graph, how do I find the point where it is I1 and I2 are equal? One thing, trial and error, you can keep finding it. Now, you check this point here, 50 and 45. So, you understand you have to go further here. But if you come here, 50 and it's below. So, you need to find out where it is same. If not, we can draw this y equals x line, guys. Because y equals x means the y-axis reading and x-axis reading, the y-axis value, x-axis value will always be equal. Y equals x graph will take a shape like this. Look at this. It will take a shape like this. On this graph, wherever you find, whichever the point you take, this point or this point or this point or this point, any point you take, their x reading and y reading will be equal. Y equals x graph, right? Here also I can draw a y equals x graph and find out where that y equals x graph cuts this graph. Then you can find out that point x and y readings will be same. That's the idea you have to do here. That will be the easy one since they have the graph sheet also. So let me draw that line starting from this point. Can you see here? When I take, like, we start from 2020. Let me redraw that again. Let's start from 2020 and see. Then it goes through 30-30 point, 40-40, 50-50, 60-60, 70-70. It connects all the equal points. This is what y equals x graph is. Y equals x graph. So you know on this graph, whichever the point you take, x reading and y reading will be same. Then you find, okay, where this graph intersects this line, I can find this point. Which means on this point, the intersection point, yeah, on the intersection point, x reading and y reading, that means I2 and I1 have to be equal. This is a little bit difficult to think in the exam. Even if you did not draw this graph, you could have at least, trial and error, you could have found that point. But drawing this graph and getting this in the exam, unless otherwise you studied that earlier, might have been a tough task in the exam. A little outside from what we usually do. Now let me get this point. Right, on both sides I am taking it. Look at this. Here it's 45, around 47.5 we are getting it. Here also in between 45 and 50, almost in the midpoint we are having it, right? Both sides the readings are same, 47.5, 47.5. That is what the I value will be. This is not deviation, I. Let's go to the calculation. We can say determine the minimum angle of deviation. When D is minimum, I1 and I2 have to be equal. In this case, we have got it to be 47.5 degree. 47.5 degree. If you want, you can write that as 47 degree, 30 minutes. Now go back to the previous equation, this one. D equals I1 plus I2 minus A. If it is minimum, then these two will be equal. You can call it 2I minus A. We studied that now. D 2I, 2 into 47.5 degree minus A, prism angle we found it. Where is that? 5902. This is 95 degree minus 5902. That is 36 degree and 35, right? 35. That is 35 degree 58 minutes. 35 degree 58. You take it as 60, then you have 35 and there is 2 minutes, so 58. 35 degree 58 minutes is the minimum deviation we get. What next? Calculate the refractive index of the glass that the prism is made of. You know the formula, n equals sine A plus D by 2 divided by sine A by 2. Write the formula first. Then substitute the values. A plus D by 2. A was 5902. D is 3558. over 2 sine A by 2. Sine A 5902 by 2. This is 5935, that is 80 94 95. Sine 95 by 2 means sine 47 degree 30 minutes or 47.5 minutes you can say. Divided by half of this, sine 29 degree 31 minutes. So you can use the sine table, substitute the values, and the answer you are getting here 1.49. 1.49 would be the right answer. But then since 30 minutes, 31 minutes you may not be able to find from the sine table, then you have to take sine 47 degree, 48 degree, get their sine values, divide by 2, you can get an approximate value for that. Do that the same for the other one also. 31 minutes and 30 minutes are very close, right? So you can take 29 degrees sine value, 30 degrees sine value, take the midpoint, that would be approximate for this, right? In the exam, for 1.49 is the right answer. They will give a little bit of flexibility. Anyone who has written 1.48 up to 1.5 will get the marks here. 1.48 to 1.50 marks will be given, right? So calculations, don't worry too much about it. Look at the method. Look at the method how we are doing it, right? This is what part of question from 2019 paper. Now let's see another question from this part, right? Another question. Right. This question is not from the past paper. This is from a leading school's term exam paper. I thought this will also be relevant for you. Doing some practice is good. I have taken this question for you. The student has done an experiment to find how the angle of deviation changes with the incident angle I for a prism. The D versus I graph he obtained in the experiment is given below. What is the incident angle when the angle of deviation is minimum? You know, incident angle is here. This is where the minimum is. Minimum seems to be at 40. As per the scale, the incident angle is at 55 degree. 55 degree. So they are asking the incident angle, which is 55 degree. Find the prism angle. Prism angle. You know, prism angle will be when D is minimum. When D is minimum, D will be 2I minus A. From this you can say A will be 2I minus D. 2 into I is 55 degree. Minimum deviation also we can find easily from the graph. 40 degree, 40. That is 110 minus 40. 70 degree is what you are getting as the prism angle. From this, find the refractive index of the prism. N will be sine A plus D by 2 over sine A by 2. Sine A plus D by 2. A plus D by 2. A is 70, D is 40. By 2 divided by sine A by 2. A is 70. That is sine 110 by 2 sine 55 degree divided by sine 70 by 2 is sine 35 degree. Use the sine table, substitute sine 55 and sine 35 and get the answers. The answer is 1.43. 1.43 is what we are getting for this, right? Next, what are the incident angles for deviation angle of 45 degree? Let's go back to the graph. Deviation 45. Let's draw a line at 45. Right. And then from here you can see can you see there are two incident angles which give us a deviation of 45 degree. What are they? One has to be here 40, this is 45, 42.5. It's not 42.5. We have to get the scale carefully. Look at this carefully. 1.5 section is what they take as 5 degree. 1.5 section. So this is half of the section. That means 5 divided by 3 is approximately 1.6, isn't it? 1.6 degree. So 41.6 can we say? This is line straight. Yeah, 41.6 degree. And what about here? This is 60. Then you will have 65 here. 65 here. This will be then 68.3. 68.3. So we have 41.6. Careful. The x-axis, like 1.5 section is what they take as 5 degree, right? 1.5 section. So accordingly, if you measure this one, right, one is 41.7 degree they have. Approximately you can say 41 degree and 0.7 means 42 minutes. And the other one they have, this is 60, 65, 68.3 degree. You can say 68 degree 20 minutes. 0.3 means 0.18, no, 18 minutes. Approximately that's what we have. So we'll write that 41.8, 41.7 and 68.3. You can write it in decimals. If you are writing in decimal, put the minutes, put the degree mark at the end. If you are writing in minutes and degrees, then after the degrees you put the degree mark. After the minutes you have to put the minutes mark. Be careful. Marks will be given for this. Marks will be given in minutes and minutes and degrees. If you write, marks will be given for that also. Explain the reasons for getting two incident angles for a given deviation angle. What are you going to say for that? You know, the ray is reversible. For I1, the deviation you are getting, that would be the same deviation for I2 also. What is I2? The emergent angle, right? So let's say the ray is reversible. Incident angle I1 and emergent angle I2. When, let's say if deviation is 45 degree for incident angle of I1, it will be the same deviation for incident angle of I2 also. Clear? So I1 and I2 are reversible. That means incident ray, refracted ray, emergent ray. If you just reverse it, on the emergent ray's path you give the incident ray, and then the refracted ray, on the incident ray's path you will get the emergent ray out, which means I1 and I2 are reversible. For the same D, I1 and I2 can be the incident angles. I have shown that very well in the theory part when I did the experiment. Draw the ray diagram for an incident ray on an equilateral prism at the instance of a minimum deviation. So see carefully, we studied a formula 2R equals A. Remember? So if it is an equilateral prism, A is 60 degree. So 2R will be 60. R will be 30. When I draw the normal here, let me draw the normal as well. Okay, let's say this is the normal. With the normal, refracted angle has to make 30 degree. Refracted ray has to make 30 degree angle. From here 30 means with this line 60, right? You know this line is also at 60. So refracted ray is also going to make 60 degree, which means the refracted ray has to be parallel to this side. Refracted ray has to be parallel. When you are drawing the refracted ray, look at this. Refracted ray has to be drawn parallel to the other side of the prism. Now look at this. This can be the incident ray. Let me draw the normal here again. The normal. And it has to deviate from the normal. It has to deviate from the normal. That's how the line will be. So there will be a symmetric diagram because the I here and I here have to be equal. Why? They said minimum deviation. I1 and I2 will be equal. So you must draw it symmetrically. Also, this line, refracted rays path has to be parallel to the other face. You know the reason? That's the reason. R is 30 degree means with the side of the face of the prism, it makes 60 degree. With this face, other face also makes 60 degree. Clear? Right. Let's mark that. Let's say this is 30 degree. This is also 30 degree. Here this is 60 degree. Every ray diagram, make sure you put the arrow I1. Both will be I1, or you can even just mark it as II, right? Don't mark it as I1 and I2. It's I, same. Deduce the angle of incidence on the first face. You know, sin I equals n sin R. Since they said glass, you can assume the n to be 1.50. Sin R is 30. Sin 30. Correct? Sin 30 means half. Sin 30 is half. 1.5 into half. .5 half, you get 0.75. 0.75. Let's use I value we are getting is 48.6 degree. 48.6 degree. Right? Approximately that is 48 degree. 0.6 means 36 minutes. With the sine table, you may not be able to get exact value like this. So at least, you know, it's in between 48 degree and 49 degree. It's quite closer to the middle value. Then you could have said 48 degree and 30 minutes. Any answer between 48 and 49, marks will be given. 48 degree and 49 degree. In between that, any answer, marks will be given. Okay. Next. Find the incident angle if the refractive index of the prism material is √2. So you know, again, same working I have to do, same working where n has to be √2, right? Let's say sin I equals n sin R. N is √2, R is 30 degree. Sin 30 is half, 1 over √2. Sin I is 1 over √2. What would be I? Straight away you can say I is 45 degree. Basics we studied what? Sin 45 degree is 1 over √2. The student has not drawn the graph for incident angles from 0 to 30. Explain why. Imagine here if the angle is less, then this angle also will be less. Then what will happen when it reaches the other surface? Let me show you. Look at this. Right? You get the ray like this. Deviation will be a little less, then you will get the refracted ray would be something like this. Let me draw the normal. Right. So imagine if this angle is less than 30, let's say I1, then R1. If I1 is less than 30, what will happen? R1 will be a small value. When R1 reduces, what will happen? The R2 will increase, right? R2 small value, it will decrease. Let me just give you the explanation first, then we will write the answer. When not R2, R1. We'll write it this way. When I1 reduces, R1 will decrease. R1 will decrease. R1 decreases means, guys, this angle becomes more and more. The R2 angle will become higher. R2 will increase. R2 will increase. What will happen if R2 increases beyond the critical angle? You know the meaning of critical angle. Critical angle is where from glass to air, the incident angle, the last angle at which the refraction can happen. If the incident angle becomes greater than the critical angle, the refraction wouldn't happen. Instead, internal reflection will happen. Total internal reflection. That means all the rays will get reflected on glass air surface. From a dense medium, from a less dense medium, when it goes, there will be a critical angle. If the incident angle is beyond the critical angle, if the incident angle is higher than the critical angle, total internal reflection will happen. That's what is going to happen here. Look at this. When R2 is greater than critical angle, total internal reflection will happen. Which means no refraction. No refraction. Understand? No refraction. This is why he can't draw the graph. What graph? I versus D graph. Because if I reduces below a particular point, then he won't be able to see here. The graph will get reflected to this side. Understand? Understand? Then we can say this is why. This is why for lower values of R, lower values of I1, the D versus I graph cannot be drawn. Cannot be drawn. So that's a good question. That's a good question. You have to think a little bit. Right, why we can't draw the graph for smaller values of I? Because then you won't see the ray from this side. So concept of deviation will not apply there, because then total internal reflection happens, which is a different concept altogether. Right. So that's the last question we had here. And then one more. Draw the D versus I graph for a prism with prism angle 30 degree and 60 degree on the same axis. Assume the refractive index to be 1.5. Let's see. Take the x-axis and y-axis. This is I, D. Let's go back and think. We had a formula D equals 2I minus A. We had another formula A equals 2R. R will be A by 2. So understand, if A drops by, see they are talking about 60 degree and 30 degree, right? So the D versus I graph of prism angle of 30 and 60, see? Okay. So we already analyzed 60, now we will think about 30. A drops by 30 degree. 60 to 30, A drops by 30 degree. If A drops by 30 degree, R is going to drop by 15 degree. You understand? R will drop by 15 degree. Then you know the relationship between I and R. Sin I equals n sin R. So understand, if R drops by a value, n is 1.5, right? Then I will drop by a bigger value. It will be dropping by a bigger value. For example, if R drops by 1 degree, the change in I will be bigger than 1 degree. Do you know why? Because of this multiplier factor. Not exactly 1.5 times, because sin is there. Still, R and I, when R changes by a value, the respective I change will be a bigger change. So here, if R drops by 15 degree, then I can say I will drop by more than 15 degree. I don't know how much it is. I have to put it into a formula and find it. But I will drop by more than 50 degree. If I drops by more than 50 degree, look at this. 2I will drop by more than 30 degree. Drop more than 30. A drops by 30. Then what happens? This drops bigger, right? The drop in 2I is bigger. Therefore, D will drop. D will drop. So you understand, when 60 degree to 30 degree, if prism angles changes, the minimum deviation will also decrease. Minimum deviation. So the minimum point will be different. 60 degree prism's minimum point will be higher than the 30 degree prism's minimum point. And another thing you need to understand, see, think if this is 30 degree prism, let's consider 0 degree incident. So this is the lowest I value you can get, right? Then there won't be any deviation here because 0 degree. This is 30. So this has to be 60, this will be 30. 30, right? If this is 30, this is 60. Which means 30 degree is the maximum incident angle. That means R2 value. On this face, this is the maximum. Why? If it is a different angle, let's say you get an angle like this. Draw the normal. Draw the normal. Now look at this one. Here you are going to have an angle, right? Which means this will be less than 6 because this is not 90. This is less than 90. If this is less than 90, this angle will be. Do you understand? This is the 90. So this line, the refracted ray, that goes at less than 90. If that is less than 90, here it is 30. This has to be greater than 60 degree. If that is greater than 60, this angle will be less than 30. So for a 30 degree prism, on this second surface, the incident angle cannot go beyond 30 degree. Why I am telling that is, the internal reflection cannot happen. Internal reflection cannot happen. Which means, you remember earlier we said, for a 60 degree prism, this is how the graph starts. Up to 30 degree graph will not be there. Up to a particular point, graph will not be there. Whereas, if it is, this is for A equals 60 degree. Why did we say in this gap there is no graph? Because in this gap, internal reflection happens. But when it is A equals 30 degree, there won't be a chance of internal reflection. That means your graph will start from here itself. So starting point of the graph, whether it touches the y-axis or not, also depends on A. So if I draw the both graphs together, look at this. Let's draw one. A 30 degree, let me draw here. If this is A equals 30 degree, if this is A equals 30 degree, right? A equals 60 degrees graph, it will start from somewhere here, right? I don't know what value it is, it will get shifted. And also the minimum point has to be higher. Can you see that? Minimum point has to be higher. When prism angle changes, there are two things you have to be aware of. One, the minimum deviation changes. If prism angle is lower, minimum deviation is lower. If prism angle is higher, relatively minimum deviation will be higher. Point number one. Point number two, where it starts. will be different. For A equals 30 degree, you can draw a line with I equals 0 and C like I have drawn here. Then you can understand this is the maximum incident angle you can get on this surface. 30 degree is less than the critical angle. Critical angle is 42 degree. Maximum you can get here is 30. That means it's always, it will go to the other side. There won't be any internal reflection. There won't be any internal reflection means when you draw the graph, you can start from here. But for A equals 60 degree, there will be internal reflection until a certain value of I, approximately 30 degree. Until then, there will be reflection, internal reflection. Then you can't have the graph in this side. So graph will be shifted rightwards. Graph will start somewhere at a point shifted rightwards. Also, graph has to be shifted upwards. When A increases, graph gets shifted rightwards and upwards. Graph gets shifted rightwards and upwards when A increases. Understand? That's a bit of a difficult one you to think unless you studied this in advance. Thinking this and answering this would have been a challenging task in the exam. Now, since I have told you this, now you know. Take an extra additional note, highlighted note on this point. When A increases, what happens to the deviation graph? Clear? So, hope you understand all about minimum deviation, how to find it, what kind of questions can come regarding this experiment in the exam, all that I have shown you. Practice this very well. We will again meet up with another experiment, practical number, another experiment with Prism.